Fishy, fishy, Oh, I mean, here we are in math class, and well, we better get to work. I can't just hang out singing important songs all day. Um, we are going to be learning about math. Yes, math. Okay. Um, and I think let's learn about fractions. I think those are important for middle school. And before we get into some more advanced fraction work next week, we need to solve a problem. For some reason in elementary school, they like to show fractions as mixed numbers like this, where there's a whole number next to a fraction. This is the whole number, this is the fraction. And it's called a mixed number because it's a mix of kinds of numbers. Whole numbers, fractions. Whole numbers, fractions. This is bad. When you get to middle school, high school, college, they do not like mixed numbers. Every year you go farther in math, you will see mixed numbers less often. And it's because they make things complicated for no reason. They don't want a mixed number. They want a pure fraction. They want all the numbers in one form. So when you get to higher level math, especially high school, college, and beyond in your job, you will use these. If you become an engineer, a computer scientist, a physicist, most any kind of scientist, you will be working with fractions and they'll use pure fractions like this. There's one, there's one. So we need to learn how to change our mixed numbers into pure fractions. Let's do that now. First, look at your 2.5. We have two wholes, and we want to write those two wholes with a new unit, and that unit is halves. Here is a way to do it visually. I take that two wholes right here, and you can see how I've written it out with two bar models. One whole, two whole. So I've got two wholes. Each of those wholes, I want to make it into halves. And so you can see how I've taken these wholes and I've divided them into halves. Now I want to see how many pieces I have together. Well, it's great. You kind of have an area model. You've got 2 times 2 equals 4. So the number of pieces I have in halves, that's my unit of halves, is 2 times 2. I've got 2 bars. Each one has 2 pieces and they're wholes, so I have all the pieces. 2 times 2 is 4, and you can see it right here. 2 times 2 is 4, and what size pieces are they? Halves. Plus, I already had 1/2 over here. So I have 4 halves from my 2 wholes, plus my 1/2 is 5 halves. Let's look at another problem. Here I've got 4 wholes. 1, 2, 3, 4. They're wholes, so I have the whole thing. I have all the pieces. What size pieces do I want to deal with? I want to deal with halves. So I'm going to split these into 2 parts each. Now we have our area model. I have 4 for this dimension, my 4 wholes. This dimension is the number of pieces, 2. How many pieces altogether? 4 times 2 is 8. Right? There's 8 pieces. They're wholes. I have all of them. I have the whole thing. 4 times 2 is 8. 8 pieces. What size are the pieces? They're halves. Now I already had this half right here. So I'm going to take that half and I'm going to add it on. 8 halves plus 1/2 equals 9 halves. And now we have changed that from a mixed number to a pure fraction, right? Mixed number to pure fraction. Mixed number to pure fraction. Let's look at another example. 6 7/10. I have 6 wholes. One, two, three, four, five, six. Oop, I made one too many holes. Let's ditch this one here. Okay, I've got 6 holes right here. Now, all of those holes, I want them in tenths so I can combine this whole number into this fraction, and my piece size is tenths, my unit is tenths, so I'm going to make tenths. Okay, now I've got 10 pieces this way, so I've got 6 wholes. Each of them has 10 pieces. There's 60 pieces here altogether. 6 times 10 is 60. What size are the pieces? They're tenths. I already also had 7 tenths right here. So I take the 60 tenths right here. You can see that it's 60 right here. 6 times 10, 6 times 10, plus the 7 right here. 60 plus 7 is 67. My piece size is tenths. 6 and 7 tenths is equivalent to 67 tenths. Now, sometimes you're going to get a fraction like this where you have a unit size, a piece size, that is a large enough number, you're not going to want to draw it out visually. And so this is going to start to become a more representational, a more abstract model. I've got my 5 wholes. And just like when we've done area models with larger numbers in multiplication, we just write the number of pieces there are instead of actually drawing them all in, instead of actually making my 99 lines to make 100 pieces. So I can just know that this is 100 pieces this way. So 5 wholes, each one has 100 pieces. 5 times 100 is 500. There's 500 pieces. They're wholes, so I have the whole thing. I've got all the pieces. 500, what size are they? Well, they're hundreds. Plus, I already had 400s. So I take my 500s plus 400s equals 504 hundredths. 5 and 4 hundredths is equal to 504 hundredths. Okay. This is how you can use a visual model to help you really understand what you're doing when you change a mixed number to a pure fraction. I want to talk about how you can show it with a formula so that you can do it more quickly without this model. Although you're welcome to use this model if you need to, there is nothing wrong with that. When you get to larger quantities, though, it becomes inefficient. Or when you have to do a large number of numbers to convert. So let's do that really quick. Let's take this fraction, 4 2/3. Now I already know if I was going to draw the model, I would have 4 wholes. Each of those would have 3 pieces. Right, and I would be doing 4 times 3 to get the number of pieces. But instead of drawing that out, let's just write it. 4 times 3. And I know there's these 2/3 to add in. Right? I know I've got 2 more thirds I want to add in. Let's just go ahead and add those 2/3. So we've got our 4 times 3. You can see it right here. Plus these extra 2 pieces. So 4 times 3 is 12. Plus 2 is 14. So I've got 14 pieces altogether. I've got these 12, 13, 14 pieces. What size are they? They're thirds. This right here is a nice formula you can use to change this to a pure fraction. You do the number of wholes you have, 4, times the number of pieces, plus the fraction you have in addition to it. Right there. That gets you that pure fraction. Let's do another. Let's say we have 100 and 5 tenths. Now here, I don't really want to draw out my 100 wholes, but I know there's 100 of them. And how many pieces do each one have? They have 10. 10 pieces. 100 times 10. 100 times 10 is 1,000. There's 1,000 pieces there. Plus the 5 extra equals 1,005. Now, what size pieces are they? They're tenths, right? And to make sure we understand where we got these numbers, this 1,000 came from my 100 wholes, and each of them had 10 pieces. 100 times 10 is 1,000, plus my 5 left over. Let's do 2 more examples. Let's say I have 5 wholes. Let's say my piece size is fourths, and I have 3/4. Okay. Now, we have 5 holes. Each of them has 4 pieces plus 3/4 in addition to my holes. My piece size for all of these is fourths. Let's do it. 5 times 4 is 20 plus 3. So 5 times 4 is 20 plus 3 is 23. 23/4. To really see it again, if you wanted the visual, 5 holes. There's my 5 holes. Each of them had 4 pieces. 5 times 4, there's 20 pieces there, plus 3 left over, right? So I've got these 20 pieces from my 5 holes. 5 times 4 is 20, plus this 3/4 in the fraction, right? My piece size is fourths for all of them. So I've got 5 times 4 is 20, plus 3 is 23/4. Last one. This time I'm not going to draw any visual model. It's going to just be abstract, just a numerical model. Let's say that we have 10 holes, and let's say that my fraction I am working with is fifths, and let's say I have one of them. Well, I've got 10 holes times 5, because each of those holes has 5 pieces. So 10 times 5, plus I have 1/5 as part of this fraction here. So 10 holes, each one has 5 pieces, plus I already have one right here. So 10 times 5 plus 1. Well, 10 times 5 is 50, so there's 50/5 here, plus one more fifth. So 50/5 plus 1/5 equals 51. Now, my piece size is fifths. There's my answer, 51/5. That's all. Bye.